All right, let's talk about analyzing this data. So in this question, you've got 10 cows altogether. Experimental group and control group. Control group means what? What's the control group? You can look at your notes. What's the control group?
Group that is used.
Group that what?
That is used.
Group that is used for what? What do we use the control group for? What's the point in having a control group? Let me pull up my popsicle sticks. Brian. Oh, there you go. Brian. Not that piece. Brian. What's the control group?
Maybe the group that could probably tell a prediction.
Okay. Can help us tell a prediction. What's the experimental group?
The group that
The group that
is exposed to
is exposed to the independent variable, which is the variable we change. It's the one we experiment on. So if we have a group that we experiment on, our control group is what we compare it to. So experimental group is the cows that got the medicine to try to make bigger babies. The control group is the one that did not. We didn't mess with them any. So based on that data, do you think the drug worked? Not here. Elijah, do you think the drug worked?
Yes.
Why do you think?
Because some of the weights of the cows went up.
Some of them went up. Anybody agree? Saying yes, the drug worked? Raise your hand if you agree. Okay, who disagrees? Who says the drug didn't work? Who says that the data is inconclusive and I don't know? Alright, so happy you raised your hand for something, so the rest of you just must not have done it. So what's going to happen is there's two ways we can determine whether this worked or not. One is to look and say, okay, this group not bigger, this group bigger, this group not bigger, this group bigger, this group bigger. So 3 out of 5 cows showed increased growth of their calves at birth. Or you could take the average of the entire group, and it's going to show that this was a little bit higher than that group. So based just on this data, we can say, yeah, the drug did work. But as scientists, we're not going to stop and say a drug worked just after 5 cows, because 2 of those cows did not show growth over the other. So yeah, 3 out of 5, it's probably leaning towards yes, there is an effect, but you need more data. But for this purposes, we're going to say yes, the drug worked because most of the cows in the experimental group had increased growth. So make sure you have the complete answers. And you can say no, but you better have a justifiable reason why. All right, once you have that written down, put that paper away. We'll get it back out tomorrow. Remember, you're going to turn that in on Friday for grade. scissors and glue for everybody at your group. Should be plenty for everyone. Now I'm gonna walk you through how to cut and glue these foldables. And I really want you to pay attention because I really don't want to have to do this again. I'm going to show you what they're supposed to look like when you're done. And then we're going to do it together. And then y'all are going to handle it from this point on. Whenever you are done with this foldable, these are great foldables for vocabulary because they work like flashcards, but you get to glue them in your notebook. The way it's going to work is when you're done, you're going to have flaps that have the vocabulary words on the front, and then when you open up the flap, the definition and examples are going to be on the inside. See how that works? So you can write first, but today we're going to cut first so that I can show you how to do it. So first thing you're going to do is cut out the bold part because the whole sheet won't fit in your notebook. So we're going to cut out the bold lines so you're going to have one rectangle. As a general rule, when you're doing the foldables in my class, if it's dark lines, you usually cut. If it's dotted lines, you usually fold. When you're done, you just got this right here. I know y'all can handle this last year. I had to explain this in March. I'm like, dude, we've been doing this all year. When we're done, we're gonna have one person carry around the recycling bin, so don't worry about getting up and throwing anything away. I know they're kitty scissors, but they're $2 for $1 at the dollar store, so that's what I got. If you want bigger scissors, feel free to bring your own. That's what we're doing next. When you're done cutting out your rectangle, you're going to cut along the dark lines on the side, so that creates your tab. So 1, 2, 3, 4, 5, 6, 7 cuts you're gonna make. Do not cut all the way across, only cut down to the dotted line in the middle. You see how this is? I'm only cutting halfway. So we're gonna cut down on the dark lines only. when you're done cutting out those tabs, you're going to fold the tabs over onto your solid side. So all these tabs, you're gonna fold on the dotted line. Press them down real good so they lay flat. And sometimes it's easier to fold the right side over to the left. However it's easiest for you. Doesn't matter to me. Alright, once you're done, you should have the flaps on top. This is where your vocabulary words are going to go. Our first vocabulary word is going to be matter, so you're going to write matter on the top of the flap. And then when you open the flap, the definition is going to go on the right side. If I have anything in parentheses, like an example, you're going to put it on the left side. So definition on the right, examples on the left, word on the outside. Is anybody confused? Speak now, for real. Okay. So on the inside, I'm not going to write it because y'all know my handwriting. So on the inside flap, you're going to be writing anything that has mass and takes up space. This is a total review for you. You've talked about matter for several years. You should know that matter is anything that has mass and takes up space. Does anybody know? Bless you.
Thank you.
There are two things in this universe. One is matter, and if it's not matter, what is it? Do you know? If it's not some form of matter, like light. Light is not matter. What is light? What is sound? I heard someone whisper. It's energy. Everything in the universe is either matter or energy. We're going to be talking about matter right now. We're not going to be talking energy too much. Right now we're just talking matter. So anything that has mass and it takes up space. Y'all know what atoms are, right? We talked about that already. You should know that it's the smallest component of matter. So it's the smallest component of anything that has mass and takes up space. And still retains the property of that matter. So this is the smallest unit that matter can be broken down. If it gets smaller than that, it's no longer that matter. So on your second flap, on the outside, you should have atom. And then on the inside, the definition. Anybody not here? Kai's not here, right? Kai Vaughn didn't sneak in? inside of an atom, in the very, very center, is the nucleus. This is like the seed of a peach. And the one in parentheses is where you should be putting it on the left-hand side of your tab. That's kind of a side note. Most of the mass in an atom comes from the nucleus. That's where the protons and neutrons are. Electrons don't weigh that much. The next step up from an atom is an element. An element is a substance made up of only one type of atom. Doesn't matter how many atoms it is. It could be one atom, it could be 20 atoms. If it's only one type of atom, then it's an element. That's where we get our periodic table of elements. For example, oxygen does not like to hang out by itself. You will never see one oxygen atom occurring in nature. Oxygen likes to be in pairs. So you'll always find regular oxygen with two atoms. So it would be O2. Still an element because it's still just oxygen atoms. It's just more than one. When you combine two or more atoms together, when they are bonded together, they are called molecules. What's H2O? Water. What's CO2? Carbon dioxide. And O2 is? Oxygen, yes. Those are all molecules. So those things in parentheses, those are examples that you should be writing on the left-hand side of your tab. This is all the foundation for all the fun chemistry stuff we're getting ready to do. When you're done copying down all the words on this page, please put your head down so I know you're done. When you're using these foldables, I recommend writing before gluing, because when you glue something in, if it's not completely dry and you try to write in it, it tends to tear the pages. Plus, like today, I have a specific way I want you to glue it into your notebook. Alright, see a lot of heads down, a couple more heads up. Moving on. Last three. A molecule, we just said, was when two or more elements are chemically combined together. Elements, atoms, when they're chemically combined together, they're a molecule. When they are different elements, they're called a compound. So molecules, they can be the same element combined together. So O2 is a molecule. O2 is not a compound. We have water, we have hydrogen and oxygen, two different elements. It's a compound and a molecule. Carbon dioxide, compound and molecule. C6H12O6. Oh, what is that? Y'all remember what that is? Think about photosynthesis. Say, yes! High five, dude. Glucose from photosynthesis. Those are all compounds. I can't put oxygen, O2, on there. I can't put nitrogen, N2, on there. I can't do that. Because it's not a compound. It's only molecules. Compounds are when they are different elements. So this stuff in parentheses needs to go on the left side of your tab. Pure substance is exactly what it sounds like. A pure substance are substances made up of only one type of element or molecule. So if I have iron, just iron, it's a pure substance. If I have just sulfur, not mixed with anything else, it's a pure substance. Just carbon is a pure substance. Non-iodized table salt. Usually the stuff we have on our table to sprinkle on our food is iodized. But if you have non-iodized table salt, it's only sodium chloride, which makes it a pure substance. I can't always say that water is a pure substance because usually tap water has other things in it. Minerals, maybe has some sediment mixed in, might have some oxygen gas mixed in it if it's bubbly water. It's not a pure substance all the time. So if I have pure oxygen, just O2, not room air because it's mostly nitrogen and then some carbon and then some oxygen. If I have pure oxygen, O2, that is a molecule and a pure substance. And the last one, we're switching gears a little bit to talk about valence electrons. Who knows what an electron is? Raise your hand if you know what an electron is. Oh, I don't see any hands raised. Let me see. Who remembers what an electron is? Good thing we're reviewing then. Do you remember, let me ask you. Anybody remember what charge an electron has? Not plus. Negative. A valence electron is an electron in the outermost shell around the nucleus of an atom. Write that down. We're going to talk more about it in just a minute. I think y'all remember what protons, neutrons, and electrons are. You just don't want to admit it. Not an element. It's a subatomic particle. Just write that down, and then we're going to do an activity. Somebody finishes writing that down first. If you could walk around with the recycling can, that'd be awesome. see a few people finish. Can somebody take around the recycling can, please? Somebody wanna get up and walk around, stretch your legs? Be a volunteer. Thank you. All right, where I want you to glue this at is in the on page 10, if you're with me on page 10, the very left-hand side of page 10. Because we're gonna have something added next to it, so I want you to spend half the page for those notes. The very left-hand side of page 10, please glue that down. Alright, once you finish gluing in your foldable on the left-hand side of page 10, and don't forget to update your table of contents. Each person in your group will take a few minutes, and I want you to construct a carbon atom using the beans and macaroni that I put at your group. On the board, you'll see what information we have about carbon based off the periodic table. This is what it will look like on the periodic table. Your neutrons are represented by the white beans. Your protons are the black beans, and your electrons are the macaronis. So take a couple minutes, and to the best of your ability, from what you remember from 6th grade, construct a carbon atom on your desk. And you can work with your group, try to figure it out, but everybody should have a carbon atom on their desk. Don't freak out if you don't remember. beans and macaroni on their desk if they're not writing. Dude, seriously. Don't freak out if you don't know it. Just try around and see what you do know. Do your best. It happens. Parents mess up too. Alright, take about 30 more seconds. Do what you can. So guess what? No, but guess.
Let's just take out every other one.
I see 1 out of 4 have something. Y'all need to have something. Try it, try it. It's okay.
Hey! What would you do that? You suck at it. Well, no, you better make 2 macaronis instead of 3.
Do what you want. If you don't want it, it's okay.
Yeah! My eye pain off.
Alright, let's talk about it. Alright, so I have 3 subatomic particles. Protons, neutrons, and electrons that make up an atom. In the center, what's my center of the atom? That was one of our vocabulary words today. Nucleus. I have 2 of those subatomic particles that hang out in the nucleus. You may remember what 2 they were. What 2 are in the middle nucleus? sounds a lot like nucleus. Neutrons hang out the nucleus. And the positive subatomic particle hangs out the nucleus. Which one's the positive? Protons. See how that works? So in my nucleus, I have protons and neutrons. That leaves electrons to hang out outside of the nucleus in the electron cloud. When we create a model on paper of atoms, we use Bohr's model, which makes it look like atoms have rings, kind of like a planet. But in actuality, electrons kind of float out in a cloud around the nucleus. But we're going to do it like Bohr does. In my nucleus, I always know how many protons an atom has by this number right here. That's the atomic number. So how many protons do I have? 6, yes. So you should have 6 black beans in your nucleus. Protons, that's my atomic number. The number of protons determines what the atom is. So if I only have 6 protons in my atom, it must be a carbon atom. That's the only one periodic table that has 6 protons. Now my number of protons, because our atoms are always balanced out whenever we can, so my number of protons, which is a positive charge, has to equal my negative charge, which is electrons. So if I have 6 protons, how many electrons do I have? 6. And remember, those float out around the nucleus. I should have 2 black beans, and then 4 more, which makes 6. So as long as you have 6 macaroni around your 6 black beans. Even though atoms are so teeny tiny that we have to use a special electron microscope to be able to see them, they do have weight. They're matter, they have mass. On the periodic table, we'll talk more about this next week, after. The bottom number, usually it's a number point something. That's the atomic mass of one carbon atom. The number of neutrons equals the atomic mass minus the atomic number. So what's our atomic mass? What's our atomic mass? It says atomic mass. 12-ish. We'll say 12. What is my atomic number? What's 12 minus 6? 6. These, in the nucleus, 3, 4, 5, 6, are my neutrons. So your atom should look like 6 white beans, 6 black beans in the nucleus, surrounded by 6 macaroni, which are your electrons in the electron cloud. Now, it just happened to work out that there were 6 of everything. That's not always the case in all the atoms. You'll always have the same number of protons and electrons, but you may have a different number of neutrons. All right, once you feel comfortable with how you constructed your atom, please put the beans and macaroni in the correct cups, and I'll come by and get them in just a second. So on the right-hand side of your vocabulary foldable, you need to record these notes. Is this jogging some of your memories from 6th grade?
No.
Oh, Lord, who'd you have? Some of you had big, so come on, go talk to them and be like, whew, whew. I have to tell you, chemistry, this strand that I'm teaching you, is a big deal on EOGs and benchmarks. They always love to dig into the chemistry. So get these foundations right. You should already have your 30 to 45 minutes scheduled for study time. Now's the time to start. You got a quiz Friday. Benchmarks will be here before you know it. So our three subatomic particles. Proton, remember P, is positive. Neutrons are neutral, which means they don't have any charge. They're not positive or negative. They're just there, making up mass and an atom. Electrons. The movement of electrons is how we get our electricity. It is a negative charge. And ideally, all of our atoms always balance out, being neutral. So we like to have a number of positive particles equal the number of negative particles if possible. All right, the last part of this page is a model of an oxygen atom. Notice we have our neutrons and protons in the nucleus. The atomic number for oxygen is 8. So I have 8 protons, and then around the nucleus I have 8 electrons. The atomic mass for oxygen is 16, so I have 8 neutrons as well. Here's where the valence electrons come in. That last vocabulary word we did. The valence electrons are simply the electrons in the outermost region of the electron cloud or the outermost shell. So in this model, I have 6 valence electrons. When you get up into higher levels of chemistry in high school, you're going to have to be able to construct these Bohr models of atoms. I'm not going to make you know all of the atom structures, how many electrons go in which ring. That's not something you really need to know for this grade level. But you need to know what a valence electron is, and we're going to talk more about that when we talk about the periodic table, because depending on how many valence electrons an atom has is what it reacts with and where it's located on the periodic table. We're going to become good friends with the periodic table. And the good news is that they provide a periodic table for you for benchmarks and EOGs, so you don't have to memorize the whole thing. That's a bonus. Once you're done copying this down, we are done. If you don't get it all today, that's okay. See me tomorrow morning or during fourth period. We will be having an assembly to have a little powwow at the grade level. It'll probably be the last bit of third period running into fourth period. When you get to your assembly, which will be in the band room, I believe, all your teachers are going to be there, principal's going to be there. I want you guys to represent. Because the 8th grade as a whole is really good this year, but I'm going to be honest. I'm not being prejudiced when I say that I think our team's the best, because I'm just going by what I see. And I want y'all to represent that. Keep in mind our new essential question: how are elements, compounds, and mixtures different? We should be able to answer this question by the end of the week.